Okay, so let's review our integral skills, our integration skills. So for this first one, I have negative 2 over x dx. You can, if you'd like to, pull out a constant, if that helps you see what skill you'll be using here. And you should recognize that this is the derivative of ln. So the antiderivative of 1 over x is negative 2 ln absolute value of x plus c. Okay, so that's just that's just a formula you need to have memorized. Or not a formula, but just a rule you need to have memorized. For this next one, this one is much trickier. So let's split this into two integrals to begin with. So I have the integral of 2 over root 1 minus x squared plus dx, don't forget your dx, plus the integral of 4x dx. So the 4x dx part, that's just going to be 2x squared plus c. Now the 2 over root 1 minus x squared, you cannot, let's put it this way, you might be tempted to use u substitution on this, and it will not help you. So let's say you let u equal 1 minus x squared. du would equal negative 2x dx, but we don't have a negative 2x. We only have a negative 2. So that doesn't work. You can't just let it be negative x squared or even x squared. You'll have the same problem where you have like a 2x, but you don't have a 2x in your your numerator. And then if you let u equal root 1 minus x squared, you still end up with a 2x. You'd have negative 2x times 1 half 1 minus x squared to the negative 1 half. Like, you have an even more complicated du, and you don't have any of that. But what you do have, factor out the 2, you get 1 over root 1 minus x squared. You have a rule that you should have memorized, which is the derivative of sine inverse. So this one is tricky. It is an antiderivative with an inverse trig function. So this is 2 sine inverse of x. And then you have plus c plus c. You don't need two c's. It's just plus c as a placeholder for both constants. So it's just about recognizing your rules on these two problems, like knowing what rule you're going to be using. And you might try to use u substitution. And that's okay if you try and then you figure out, okay, I can't use u substitution. But just know, you can't use u sub for everything. Sometimes it's just a weird rule, like a sine inverse problem. All right, for this last one, I have an exponential function with a base of pi to the x. So if you think about the derivative of pi to the x, pi is just a number. So that would be ln of pi times pi to the x, if this was exponential. But it's not the derivative, it's the antiderivative. And so instead of multiplying by ln of pi, we're going to be dividing by ln pi. So this is going to be pi to the x over ln of pi from 0 to pi. So that is pi to the pi over ln pi minus pi to the 0 over ln pi, which gives me pi to the pi minus 1. Anything to the 0 power is 1, and then ln pi. So a lot of pi's, it's kind of confusing, but it is just using, again, one of the rules that we know, which is the derivative or the antiderivative of an exponential function.